Our energy resources come in all sorts of sizes and shapes and types. For instance, they can be solid, like coal and biomass. They can be liquid, like petroleum and water. And they can be gas, for instance, methane or natural gas, and even our atmosphere in the case of wind. It doesn't have to be renewable or non-renewable for any particular type. Renewables as well as non-renewables can be solids, liquids, and gases. The physical units of these particular energy resources are often used to measure how much we acquire and also how much we consume. So, for instance, how many tons of coal were extracted, how many cubic feet of natural gas were burned, how many barrels of petroleum were imported, how many gallons of gas did you put in your car, and how many kilowatt hours did that power plant down the road generate over a course of, say, a week, a month, a year, etc. In order to talk about these different types of energy resources, we need oftentimes a common denominator or a strain of discussion that's common throughout. And the way we acquire that is that we convert the various different types into a common unit of measure. And that unit of measure compares the heat content of these different resources. In the United States and throughout much of the developed world, we use something called the British Thermal Unit, or BTU, and that's used to compare the heat content of different types of energy resources. So the definition of a British Thermal Unit is the quantity of heat that's required to raise 1 pound of water 1 degree Fahrenheit. Now, this pound issue and Fahrenheit issue, admittedly, for much of the world is a little antiquated. Much of the world uses kilograms and Celsius. However, in this industry, BTU and the definition of BTU is still widely used and will be seen throughout the course. So expect to see more of BTU as you get deeper into this material. You can think about one single BTU as the energy that's released by burning one wooden kitchen match, which, if you think about what that looks like, it's about 1.5 inches or 3 centimeters long or so, and if you burn that up, you are basically releasing 1 BTU. Beneath this, we've got our table of energy resources and the resultant heat content measured in BTU. So looking at a barrel of crude oil from which gasoline and diesel come, that barrel of crude oil, which contains 42 gallons, in and of itself a little bit of an odd number, but that barrel contains 5.8 million BTU. If you refine that into gasoline, a single gallon of gasoline will be 124,238 BTU. Now that gasoline can vary. We're talking about an average here because, at least in the United States, gasoline can be blended, and often is, for summer blend versus winter blend, and also it can be blended with ethanol in order to control emissions and to support the farm industry. So this number here, 124,238, is basically an average. Notice that the diesel beneath this has more energy in it than the gasoline above it. So if you have a car that runs on diesel and you have a car that runs on gasoline, 1 gallon of diesel versus 1 gallon of gasoline, you will literally have more energy in your tank if you have a gallon of diesel than if you have a gallon of gasoline. Beneath that, we've got a cubic foot of natural gas, 1,023 BTU. 1 gallon of propane, 91,333 BTU. A short ton of coal, and before we get into the BTU, that short ton is the ton that's common in the United States, and that's 2,000 pounds. So whether we're talking about just a ton or a short ton in this class, we use short ton 2,000 pounds in terms of what that means. Ton in other contexts can be a little bit more, but we're going to use 1 short ton, 2,000 pounds. That's 19.8 million BTU. And finally, interestingly, a kilowatt hour can also be converted into BTU, and the standard number for this is 3,412 BTU for 1 kilowatt hour of electricity. So using the British Thermal Unit, we can compare different consumption rates of different energy consumers. For instance, using this example, let's say last year, 2 homes used 2 different types of energy resources to stay warm and to heat their water over the course of, say, 1 year. Home number 1 used natural gas, and 92,000 cubic feet of natural gas flowed into that home, and that home then was warm and also had running hot water throughout that whole year. Another home number 2, did the same thing, but instead of using natural gas, they used propane. That home used 850 gallons of propane in order to accomplish the same warmth and water heating that home number 1 did. So if we're looking at natural gas, we measure it in cubic feet, but we're looking at propane, we measure it in gallons. Which home used more energy? Well, you can't compare the two straight. You have to find a common denominator, a common mode of comparison, and that's the BTU. So home number 1 used 92,000 cubic feet of natural gas. Each cubic foot has 1,023 BTU in it. So you multiply this 92,000 times 1,023, and you get home number 1's resource use, 94,116,000 BTU. Home number 2 used, of course, propane, and propane has 91,333 BTU per gallon. So you multiply the number of gallons by the number of BTU in each gallon, and you get home number 2's total energy consumption in terms of heating the house and also heating water. And we see that home number 2, in order to accomplish the same task, used 77,633,050 BTU. So looking at these two now, we have a common unit of measure, BTU, and we can see that home number 2 used less energy to accomplish heating the house and heating water than home number 1. This kind of comparison would be impossible were it not for a common unit of comparison, the BTU. So last year, home number 1 used more BTU, or you could say home number 2 used less BTU, or fewer BTU. If we look at another example, in terms of countries, we can ask the question, which country produced more energy? So we have here, last year, 2 countries produced 2 different energy resources for domestic and foreign markets. Country number 1 produced coal. Country number 2 produced petroleum. Coal is a solid, petroleum is a liquid, and coal is measured in tons, and petroleum is measured in barrels. How do we know which country produced more or less than the other? Again, we need that common unit of measure, the BTU. And so we have country number 1 creating for the domestic and foreign markets 2.12 times 10 to the 15 BTU, an enormous number of BTU, because we're multiplying the number of tons produced by the number of BTU in each ton, and we get this large number. Country number 2, by contrast, produced petroleum, and we have this 347,480,000 barrels of petroleum, and each barrel containing 5,800,000 BTU. So you multiply the 2, and you get 2.01 times 10 to the 15 BTU. So now that we have BTU in each answer, we can easily compare the two, and we can say last year, country number 1 produced more BTU than country number 2.